We will have a simple example later on. Now, according to this criteria, we could start selecting a suitable inverter and its configuration for a system. We click Start. It's the same thing that happens when you click the green arrow icon. Now, each inverter has a score from 100%. The highest one will be selected. This is our criteria. Minimum number of inverters and MPP channels. Number of configurations is as few as possible to reduce costs. We already selected utilize MPP as even as possible in the criteria. PV Sol recommends an optimum sizing factor of 105%, means that the DC system size is 105% of the rated AC output. Difference in size factor is that if there is another configuration as 1/18 or 2/9, then each configuration has a sizing factor, so that the difference between both is minimum. We can see some information here. This is the maximum current under the peak of the PV panels. It's 7.1 ampere. And the inverter maximum input current or maximum allowed input current is 11.5 ampere. So it's okay. The sizing factor here is 104.3, dividing 3.6 kilowatt peak output of the PV area by the AC active power, which is 3.4 kilowatt at cosine phi equal 1. If we come back and change the power factor so that it's 92%, the inverter will be oversized by 8% as we has mentioned before, and the selection would be changed. So let's see what will happen. Let's recheck. This is the recommended inverter according to our criteria. Now, what we can see is that the inverter AC power rating was 3.45 and now it's 3.7 kilovolt ampere, so we can get an active power of a close value to 3.4 kilowatt. Now back to cosine phi power factor equal 1. This is the recommended configuration. One string containing 18 modules in series. The minimum voltage at the peak at 1000 watt per meter square and at 70 degrees Celsius is measured, and also the maximum at 15 degrees Celsius. We can see it here. Minimum voltage is again the voltage at the rated output current. The rated output current is 7.1 ampere. It makes sure that even if the maximum output of the PV modules is obtained, the voltage at 15 degrees Celsius, 1000 watt per meter square, and 70 degrees Celsius, 1000 watt per meter square not exceed the tracking of maximum power ratings in the inverter MPP channels. At 7.1 ampere, the voltage is 29.8 volts approximately. If multiplied by 18, as the connection is 18 panels in series, the voltage will be equal to 536.4 volts or approximately 533 volts. At 70 degrees Celsius, surely due to heat the voltage will be lower. So here it's approximately 23 volts. So 23 multiplied by 18 is 414 volts. Back again. Those are approximately minimum and maximum voltages, and those are the inverter's range. The same goes for the maximum open circuit voltage or open circuit voltage at 7.1 ampere. It's a result of 40 volt multiplied by 18, giving us 720 volts, which is below the inverter rating. And also all of the other parameters are within ranges of the inverter and its maximum power point tracking channels. This is the number of the inverters and the number of strings. Notice that the strings are only series modules connected. If 3 strings are connected, then they are 3 parallel ones, each string containing modules connected in series. If you oversize the panels or the module's output power to be more than the AC rated power of the inverter, in some cases you would have a great benefit. If we compare two system energy output, one below the AC rated power and another one which is higher than the AC output power rating, we can see that when we increase the number of modules and oversize the panels or the modules, yes, we lose some energy at their peak, but at the morning or the afternoon they don't work at their peak, so we get higher energy. We can notice that all of the DC power were converted to AC power as the rating or the active power is below the AC rating of the inverter. And the energy gained is way more than the losses, and also the total energy gained is more than those panels rated at lower than the maximum or the rating of the AC side of the inverter. Lastly, you can check the inverter specs here and also its characteristics curve. When you see all the check marks green, then you can go to the next step. Remember, you can select the inverter and the configuration yourself, or Lab PV Sol recommends it for you.